Today we will discuss about a topic of set theory. In everyday life, we often come across the various sort of examples of collection of objects, such as collection of cards, the pack of cards, the cricket team, the member of hockey players. Often these in mathematics, we consider these as a collection of a well-defined objects. In mathematics, basically we discuss about various collection of objects such as a collection of vowels such as A, I, O, U, E, and a number of collection of odd numbers like 1, 3, 5, 7, 9, so on, and even a collection of the rivers of India. We can mention a few rivers in it. Next to that, we can discuss about like various sort of alphabets like A, B, C, D, E, F, and so on. But in mathematics, what is a set? A set is a collection of well-defined objects in which an element possesses a definite property. So to illustrate an example, I would like to talk here about the few sets, like the set of the natural numbers, which is denoted by a capital letter N. It often designated as 1, 2, 3, 4, 5, 7, and so on. Moving to the next, we talk about integers. They are like plus minus 1, plus minus 2, plus minus 3, plus minus 4, and so on. And for example, if I talk about the river Nile among the set of the elements of the river of India, so Nile is not considered to be an element of the set. Why? Because Nile does not designate a river which falls in India. On the other hand, if we talk about a river Ganga, that is obviously an element of a set of the rivers of India. So specifically, the sets are denoted by a capital letter A, B, C, D, E, F. That is according to the preference of the recipient who wants to write it. Whereas the elements are written as in small letters A, B, C, E. We do not designate it by a capital letters. So there are the various forms of set. If that is, the sets are written in the various forms like set builder form and the roster form. So talking about to the roster form, what is the roster form of a set? If we talk about this roster form of set, in this the elements are being listed. Suppose a person says to list list of vowels. So we write the elements in braces, that is a curly bracket, and each element is being separated by a comma. For instance, braces start A, comma I, comma I, comma O, comma U, and the brace is closed. So moving on to the next, what is a tabular or a set builder form? On the other hand, the set builder form is a form in which an element possesses a specific characteristic in which elements or have a common property. So if we talk about elements of a natural numbers, so it is often written in the braces also. An element is designated by a small letter X, Y, Z or any other. So it is separated by a colon. After that, a common characteristic property is being written. For instance, if I talk about to list a number of natural numbers, I will start with the curly bracket, X separated by then a colon. X is an element of natural numbers. The brace is closed. So if I wish to write the same in this roster form, it would be written as braces start 1, comma 2, comma 3, comma 4, comma 5, and so on. So if an element belongs to a specific set, for instance, if I say as capital A is a set of vowels, so its elements are A, E, I, O, U, fine, and I say that A belongs to a set A. If an element does not belongs to if element is not contained in the set, we say that B does not contained in A. So here are the few distinctions between whether a set, whether an element belongs to in a specific set or not. So moving on to the next, we talk about what are the various forms of set. So there are various forms of the set, such as what is a finite set? A finite set is a set which has finite or a definite number of elements. For example, which we can count. If we talk about again odd even numbers up to 6, we have 2, 4 and 6. So we can count the elements. The number of elements in the set are 3. If on otherwise the element is called, otherwise a set is called an infinite set in which we cannot count the numbers. So for instance, a set of whole numbers, we started from 0, 1, 2, 3, 4 and the set goes on and we cannot count them. Then there comes a singleton set. Singleton set means a specific set has just a single element. If I say that name an element which is an even prime, so we will list it as only a set 2. So another type is a null set or a void set. It's very clear from the definition or the word itself that the null set or the void set has no element, is simply a null set. And we denote it by a phi or the empty set in the braces. So there are also the further distinctions of the set. What is a subset? So if I have two sets, like we have two sets, set A and B, and then A is called a subset of B if every element of A is an element of B. That means whichever elements are in A, they must be or they must follow in B. For instance, if I talk about like rational numbers and the real numbers, all the rational numbers are contained in R. So we say that the rational numbers is a subset of a real numbers because the real numbers have the elements from minus infinity to infinity, and in between that range, the rational numbers also fall. On the other hand side, if we talk about the natural numbers and the real number, the same thing follows here because the real numbers is the set from the minus infinity to infinity. It includes all the decimal places, all the natural numbers, all the odd numbers, or the real numbers. So if we talk about integers, they are also considered as a subset of a set R. Then comes another topic, that what is a power set? A collection of all the subsets of a set of a specific set is called a power set of that set. What is a power set? Like if I have elements like 1, 2, 3, what are the possible numbers of a set we can form from it? For instance, we can form a 5 set, a singleton set 1, a singleton set 2, a singleton set 3. Then moving on further, we can form 1, 2, then 2, 3 and 1, 3. And even the last one is 1, 2 and 3. So all these set, if they are written in the curly braces, then we say that that is called the power set of a specific set. That means every element of a power set is a set itself. Then moving on to the further topic, I would like to discuss what is an equal set. Here equal itself indicates that the two sets are equal. They have equal number of elements and even the elements are also same. For example, if I have elements like 1, 2 and 3, on the other hand, I have an element 3, 2 and 1. We can see that they have 3 elements in all and all those entities are also the same. The order in which they are arranged is hardly matters. So the equal set indicates the number of elements stays the same. Next comes the union of the set. Let I have two sets, set A and B. Then a union of A union B designates that all elements of A and B both. That means the union set contain the elements of A and B. But that does not mean that each element would belongs to A and B. But there lies elements of A, there lies the element of B, but they are not common to A and B. Moving on to the next is intersection of the set. What is an intersection? If the intersection of the set A and B is the set of all the elements which are common in both A and B, that means we have to write the common elements. For instance, if I talk about the even numbers, A is a set of even numbers, that is 2, 4, 6, 8, 10, 12 and so on, and B is a set of even prime. So that is the only singleton set 2. So if I talk about what is A intersection B, so the common element in set A and B would be only element 2. So A intersection B, there's a singleton element 2. For to illustrate an example, for union of the sets, if have the A is the set of vowels, that is A, E, I, O, U, and B indicates a set containing the elements A, B, and C, then A union B would be elements of A and elements of B both. So it would be A, B, C, E, I, O, U. That's all for the introduction part. What is the set theory? This is just the basic, and we will move on to the further topic later. Thank you.